Okay, for question 4, it says that the curve y equals 2 natural log 8 minus x meets the curve y equals x at some particular point x equals alpha. So it's looking for the root of the equation x is equal to 2 ln 8 minus x. Now when we're looking for a root, we want to try and use the sign change rule. In order to use the sign change rule, the first thing we always do is make our equation equal 0. Okay, so I've moved the x to the other side so that I've got equal 0. That will allow us to see a sign change, hopefully. So if we now work out, so if I call this f of x, then f of 3 is going to be 2 times the natural log of 5 minus 5. So I'll grab my calculator and work that out. And that's giving me a negative value. I've got minus 1.781 there. Now hopefully if I work out 4, I'm going to have a positive value. So 8 minus 4 is 4. Oh, that should have been a 3. Sorry, this should have been a 3 here. So that value is wrong. So 2 ln 5 minus 3 is 0.218. So that's positive. 2 ln 4 minus 4, if I work that out as well, yeah, I get a negative value. Okay, so that's 1 mark so far. We need to have a conclusion. So I now need to say that I need to note that there's been a change of sign. So sign has changed. Therefore, at least one root lies in the interval 3 to 4. So we know there's 2 rules for the sign change rule. The sign has to change, which means there's at least one root, but that's only true for sure if the function is a continuous function, which it is. It will always be, otherwise you wouldn't be asked the question. So we need to say at least one root lies in the interval 3 to 4, since the function is continuous in the interval. So basically that means there's no asymptotes between 3 and 4. It means that x can take any value in that interval, which it can. We only can't have negative logs, which we've not got happening here between 3 and 4. We would if like x was 9 or 10, that would give us a negative log, but we're not looking between 9 and 10, we're looking between 3 and 4. Okay, question part B is an easy question if you know what they're after you doing. They're not actually wanting you to use the iterative function to find the approximate value. They want you to use the graph. They say it in the question, use the graph. We've got it written here, look. So, in order to use the graph, and it says starting at 4, we're trying to look to see if it will converge at 4, if it will converge around the function. So what it wants us to do is show that So what it wants us to do is show that when we substitute our 4 in, it wants us to show what happens when we use this iterative function, but it wants us to show it graphically. So we substitute 4 in. 4 goes in here. What comes out of here is the value of y for that particular point. So we're going to input a 4, we're going to output this value. That value is then the next value that's used for x. So that value that comes out becomes the next x value that goes in. So that will take us from here to here. That value then goes in, so whatever this value is here, so say like 3.8, 3.7, we don't know what it is, but that value is then going to come out here as the new y value. That y value becomes the x value, and that x value then becomes the next y value, and so on. Line's rubbish. So that, let me zoom in a little bit, goes round like that. Now that is called a cobweb diagram. Okay, and we have to be able to recognise a cobweb diagram, and it's because it's closing in like a cobweb. The other option is a staircase diagram, which happens when the gradient's positive. We've got to put a negative gradient here, and we always get a cobweb diagram when the gradient's negative. So that gets me a mark for that diagram, and I need to explain what's happening. So it says determine whether we can use the iterative function that we've got to find an approximation, and the answer is we can. So yes, the function can be used to find alpha, since the graph forms a cobweb. That will definitely get you full marks for that question.